This is a YouTube for EE211 Programming for Engineers. This chapter that this YouTube covers is Chapter 4, so more program control structures. So in particular, in this chapter, Chapter 4 from your DTOOL and DTOOL textbook, we are going to cover the for, switch, and do while control structures, and also the break and continue statements. Which allow us to break up our iteration. So I showed this slide in the last video, but I'm going to show it again. So these are all of the loop structures that we're going to deal with. We already did the while loop in the last chapter, and just to review, it's called a pretest loop because you test some condition before you and if the condition evaluates to true, then you evaluate what's in the body of the while loop. So the test happens before you evaluate anything in the loop. And then we have another one, which is a for statement, will be the same way. And then we'll look at a iteration structure that is a post-test repetitive structure, in which case you will do something and then put the test at the end. So we'll cover the rest of the do while and the for loop in this chapter. And I think we also are going to cover the multiple choice one, the switch statement. And then we have modifiers, which are called break and continue statements, which will allow us to exit an iterative loop early if some condition is met. So I'm going to review for a moment the while loop that was introduced in the last chapter. We had both a counter-controlled while loop, which means it goes through the loop a predefined number of times. This is often called a definite iteration. And you could have a sentinel-controlled while loop. Your full homework problem, programming problem, was a sentinel-controlled problem. So you kept calculating the interest and payment, or the amount of money until the user was done. So that would be an indefinite iteration while loop, or also called sentinel controlled. But I have an example just as a short review here, and I want to point out a few features about the while loop. Just a second here, let me get my little pen going so I can write on this slide. That looks good. I like that. Let's pick a color. I like color. So a few important features to point out on the structure of a while loop, besides you already know that there's some tests. If it evaluates to true, you're going to do what's in the curly brackets. But I do want to say that before you ever enter the loop, a few things to point out. The variables must be initialized. I cannot just come in here and say while k less than or equal to 5 unless I've initialized k. There is an exception to that, but for now, let's keep that in mind, that you must initialize your variables before you enter the while loop. Actually, it's the for loop that has the exception. Okay, never mind. We'll get on to that. So you must initialize before you enter the loop. And one of the other things about the loop is while you're in the loop, something has to control the loop. And so that's this statement here. K has to be incremented. If you don't increment K, your loop isn't going to do anything. Or if you make K to go the wrong direction, let's say I said K minus minus, so every time passed through the loop, K will decrement instead of increment, and then that will become what we call an infinite loop. But we don't want to have an infinite loop. Your program is basically crashed at that point. A couple other things I did just to add variety to this program. Notice that when I did the printf statement, I have an integer control structure right here, and then I tabbed over, and then I did another integer control structure before I did a new line. And so I printed out two things, so it's kind of in tabular form, which is kind of nice. I also did the same thing right here with the headers above this column of information. So now that was a short review. Let's move on to our new control structure. Oh yeah, before I move on, your book shows a shortcut way where you do a increment before the k right here. There are examples with a counter. This is a shortcut method and saves a line of code. It's good if you're gotten really good at programming, but this actually makes it clear and makes you unlikely to forget the fact that you have to have some kind of way to increment your loop. So please stick to this way and not the shortcut cryptic way that your textbook shows you. So now let's talk about the for loop. This is the example in your textbook, and I'm going to point out a lot of features of it, and then I'm going to show some examples, and then I'm going to show you an issue you're going to run into because we're using the GCC compiler. So the general structure of a for loop is that you have, here's the for loop, you have a variable, a counter that you have to initialize, you have a test, or that you have to, a test is the counter less than or equal to 10, and then you either increment or decrement the counter. Remember, in the while loop, you do that in the body of the while loop, and you have to do that. But here we have everything kind of all in one line. So as long as counter is less than or equal to 10, I'm going to print the value of counter. This data type is an unsigned int in the in this particular for loop in your textbook. I'm fine with just saying int. I don't have to declare it as unsigned int if I don't want. I can even go negative numbers in my counter, in my loop iterator counter if I want. Let me look a little closer at this statement, and then I'm going to point out the things, some more things about it. So for is a keyword. It's a C keyword that you can't call something else for. So for is special keyword recognized. You must declare your data type for your counter. As I said, I'm fine with you just declaring it an int. A counter cannot be a float, for example. Or can it? Maybe it can. But ints are the typical. No, it can't be it can't be a float. It has to be an int. But I'm fine with you just saying int and not unsigned int. So this is called your control variable name. Your textbook likes to use counter because it's the first book in programming, but seriously, you can just use a single letter. When you name other variables, parameters in your program, you have to give them meaningful names. But if you're just using something, you just need something to count how many times that you're going through the loop, you can call it IJK, ST, XY, whatever. Single letter is good enough. Here's the condition that we must test. So the loop will continue as long as this evaluates to be true. And then here's the increment control. You increment or decrement the control variable, however whatever your loop requires. These parts are all in parentheses. There is no semicolon after the end. The next thing would be your curly brackets, which would be the body of the for loop. Even if you only have one line of code that goes in the body of the for loop, like the last example where we just had this print statement, please put it in the curly brackets. That is good coding practices, and you won't get messed up if you do that. You're less likely to get messed up. And then another common error is that people will forget to put the, well, they'll try to put a comma here instead of semicolons. So don't miss that. So let me show you another example here. Here is my example coming up. Actually, let me just show you the part I want to show you of it. So just showing you this for loop by itself. If you tried to compile this program right now, you will get an error, and it will say something about first use of the variable s not recognized, or something in that sort of terminology. Actually, I have it. There it will say error s undeclared for first use in this function. So it didn't recognize it, and it failed to compile my program. This is because we're using the open source GCC compiler, and there is more than one compiler out there for you to compile C programs. But we are using open source GCC, and in order to make this for loop work as written, we have to compile with an extension called the C99 extension to standard. So you have to put this little statement at the end of your compile command. It actually looks like I just did it a moment ago. I compiled it. There, I pasted it on. So you have to compile this program by saying GCC. This was the name of my program. Control structures.c was my source code, and then I named the final executable control structures. But at the end of the line where you normally give this compile command, you have to write a dash standard equals C99, and then we'll recognize declaring int within the for loop condition structure here. If you do not want to always type in compiling with the dash standard, with the option standard equals C99 for the C program C99, your other choice is, and I will pull up the code right here, bring it down here so you can see. The other choice is declare your int before you enter the for loop like this, and then do whatever you want to do in the body of the for loop. So just like the while loop, you can declare the data type before you enter the loop, and then you can make the loop structure right here. Now, when I look at this piece of code, fun stuff, let's put my new line in. When I look at this piece of code, what does it print out? It initializes s as a 0. S starts at 0. Int s equals 0. Hang on, pause. Not pause, that's correct. So there, I declared s before I went in. Here I initialized it to the value of 0. And so it starts at 0. My test is s less than 3, and then I go through, if s is less than 3, I'll go through and print the value of s, then I'll come back and increment s. So what does it print? Does it print 0, 1, 2, 3? Does it print 1, 2, 3? What does it print? There's a thing called off by 1 errors, and I'm going to kind of point that out to you here in just a second. I'll show you what your choices are. So let's say you need to have an iteration in a loop occur, and you want it to occur 4 times. So I have 2 snippets of code here. In this case, I initialize s to 0, and I say for s less than 3. This particular loop will print out, actually what it will print out, it will be if I were to execute it, I'll get 0, 1, and 2. That's what will print out. This second for loop structure initializes at s equals 0, and the test is to s is less than or equal to 3. And this particular one will print out 0, 1, 2, 3. So I get my 4 iterations in this loop. Another kind of thing that can happen, that people often do, maybe they start their counter at 1. So if I started this at 1, I would get 1, 2, 3, and I would have only 3 iterations. So I could say, make this be 4, and I will get 1, 2, 3, 4. So there's 2 things. One is how many times you need to go to the loop, and then make sure you set the structure up correctly so you go through the loop the correct number of times. And the other thing, here I've used my loop control variable s. I've used it, I've printed it out, but it's not required that in these curly brackets I use s. I could go through some calculation 4 times and never ever use s in the calculation. So you don't have to use s in the body of the for loop. So a few other notes and observations coming up. I'm going to elaborate a little bit more on this section, more than what your chapter did. Give you a few examples here. So first I have a couple of snippets of code. Again, this first example of the for loop. Pen. Okay, so there's no reason why I have to increment or decrement by values of 1. So in this case, I'm incrementing by values of 10. When I do this little piece of code, I print 0, 10, 20, 30, 40, all the way up to 100 because it's less than or equal to 100 and it started at 0. No problem. I can also decrement. Here I have start at s equals 5, and then I say for s greater than 5, but then I decrement s by 1. If I don't say by 1, I could say minus equals 1, or here I could just decrement it. If I ran this piece of code right here, I get absolutely nothing. Why? Because the first evaluation of the value of 5, I started s equals 5, then I do my test. Is s greater than 5? The answer is no. So nothing will get printed, and in the code I will go to the next line of code outside the for loop, whatever it was. If I had written in this piece of code less than 5, so I start with s equals 5 and I do a test. Is s less than 5? Yes. Print s, then decrement s. And what's going to happen with this one? If there's no stopping. Every time I go through this loop, s is going to be less than 5, and it's going to become an infinite loop. Bad thing. Your computer is going to just be hung up forevermore, printing numbers going into the negative direction. If you accidentally in your programming created an infinite loop working on your homework, press Control and break keys together to get out of your infinite loop. Your only other way to get out of your infinite loop is to shut down your computer. And that's not nice to do to your flowchart for a for loop. Remember, this is a pre-test loop, not a post-test loop. You initialize your variable, you do your test. If it's true, you do whatever's in the body of the loop. Then you increment your control variable and go back and repeat the test again. So it is a pre-test because the test is performed before you execute the body of the loop. So example, they call it figure 0.5. In your textbook is a pretty good example using the for loop. In this example, you had to sum all the even integers from 2 to 100. So you ask yourself, does that include 0? Does it include 100? So think about the endpoints on this loop and whether or not the endpoints, the 2 and the 100, are supposed to be included. So I read that from 2 to 100 means inclusive, including both 2 and 100. So I start with the sum, initialize the sum to be 0. And keep in mind, if you compile this program, you have to compile it with the dash standard equals C99 option. Otherwise, declare your unsigned int variable called number outside the for loop. It also makes this statement not be so long. So I do include the value 100, I do increment by 2, and the current sum gets added to the value, adds number to the current sum, and it adds up. And I print f as the output as an unsigned int. Okay, no problem. Once again, when you do your homework problems, I don't mind if you just say int. There's no really good reason on these small programs to declare it as an unsigned int. Okay, next example we have is a little bit more to it, and I will point out some new features that you'll see in this program. So this is a program where you have to do compound interest calculations. So in other words, like buying a car, you have to pay interest. This is the formula that's applied. So in this case, a person invests $1,000 in a savings account that yields 5% interest, and that should say annually per year. And assuming that everything is left in the bank, calculate and print the amount of money at the end of each year for 10 years. And this is the formula. So A is the final amount, P is the principal value or the starting amount, and R is the interest rate, and you'd write 0.05 for 5%. And N is the number of time periods that you're going to calculate the interest. So N is 10 in this case because you're doing it for 10 years. So this is the formula. You are not going to write this formula 10 times in your program. It's a repeated calculation that you have to make, but you're going to let a for loop do that for you. Never again in your code do I want to see a repeated calculation like printing the asterisk 95 times. I wouldn't want to say print f asterisk, print f asterisk, print f asterisk 5 times. You would have to put that in a loop from now on. So now let's look at the code. I have it already. I brought it in already and did it. There's a few new things. One, the formula here involves something raised to the power of some number, something in parentheses raised to a power. It's 10 times, but I don't have a mechanism right now to raise something to a power. So, whoops, didn't mean to do that. So what I have to do is use some of the math libraries that are included with C. So far we've only been using the standard input-output functionality that's been made for us in C. Now we're going to start to use math functions. This will include all your trigonometric functions, your just a lot more mathematically interesting functions are included in the math standard, in the math libraries. So I have to include math because I want to raise something to the power. It happens to be to the power of 10. So let's look at the program. I'm not using ints. I'm going to declare a double because that's the highest precision. Money things are usually done in double. So the principal was $1,000. Note that there's a decimal point right there. The rate is 0.05. See, I can't declare an int because 0.05 is not an int. And then I'm going to put a headers on my columns before I output the data. So let's look at what's happening in our our format specifier right here. So it actually is saying to give 4 spaces for string and 21 spaces for amount on deposit. I suggest you play with this statement, change those values, and see how things print out, because it will vary how things print out. Here's my for loop. I'm going to repeat the calculation 10 times. So the starting year is 1, and I'm going to do it through the 10th year. So year less than or equal to 10, and then I increment year. This is the formula. So I have used the power math function. So it's power, this is the base, and this is the exponent. Oops, here. And so power is a function, so the 2 arguments that go here are in parentheses. And then I put the final answer out. Year and amount are the 2 things I'm going to put in a column form. Year is an unsigned int, so I have a U here, and I'm giving myself 4 spaces to put the U in. Amount I'm giving myself 21 spaces, but I'm also allowing 2 spaces for the cents, it's the fractional amount of $1. I don't want to put 4 spaces because it's not $150 and 5000 cents. It will be, you express things in dollar amounts, so there should be a .2 there. So a little bit more about the math libraries that you have. If you go over on Laulima and you go to the resources folder, I'm in Laulima, go to the resources folder, and there's a folder in there called references, and one of the references is this C reference card.pdf. So I have it opened here. Let me show you it. Here it is. So here's the C reference card. I know it's a little tough to see right now, but right here are, down to the right, are the ANSI standard libraries. I'm going to zoom in. ANSI standard libraries. If I look down here, here's the standard libraries that you can use. For example, we're using standard IO. You can see standard IO is a library. We'll use more libraries as time goes on. Standard IO is a library. Math.h is a library. Well, it's a header in your program that will allow you to use the library functions. And there's some other ones in here that we'll talk about later. A string is going to come up here soon. If I look more at this C reference card, zoom back out here for a minute. There is also a list of all your data types. So zooming back in here on all our different data types that we can have, many of which that we've already spoken about: an int, a float, a double, longs, and unsigned, and pointers we'll talk about soon enough. But anyway, here's a list of all of the data type declarations that we have available to us, the keyword data types anyway. If I go on to page 2, other important things, it tells you something about what comes in each of these libraries that you can use. Like here's the time.h library and what time functions you have. Here's the mathematical library, the math.h library, and what functions you get with math.h. So math.h, you get sine, cosines, tangents, arcsines, arc cosines. And anyway, you can see, and there's POW. So POW has 2 arguments, x and y. Just to let you know that POW, though, the x is the base and the y is the exponent. No comments there. Okay, but that's the format. So here's a list of all your math libraries. Anyway, so this reference card is in the Laulima resource folder. You can refer back to it, especially when I have you do more math functions, which I will be having you program more math functions. So once again, that's about the standard I/O, and now we are also including math.h. Your textbook also mentions that you could do a -lm when you compile the code. I haven't tested it. I always include -lm when you compile the code if you are on a Linux machine. But I think most of us are on either a Mac or a Windows machine. But feel free to try that. Looking at what the format of the output of our program would look like, here was the header information that we printed with this statement right here. So it was 4S and then a 21S. So if I look at that, there are, with my pen, 1, 2, 3, 4 spaces here. And I printed a string, and here to here will be 21 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This part right here takes 17 characters, so then I have 4 more spaces right here to make a nice space. And then how did we format our numbers, our numeric output? Looking back at our little piece of code here, our numeric output was 4 spaces of unassigned integer and 21.2 spaces of floating point numbers. And I think this should be an LF to correspond to, should say LF there, to correspond to using doubles, not just F. So what do I have? I have my 0.2 right here, so I'm not displaying more than that after the decimal place. And then between here and here, I'm giving myself 21 spaces. So those format specifiers were used to make our output look really nice and versus messy. It's interesting, in the textbook it says don't use type float or double to perform monetary calculations. I don't necessarily agree with that, because in other textbooks that I've used in the past, it says double is often used for monetary calculations. So I think what you have to really be careful about is when you specify the number of digits past the decimal point. Our next control structure is called the switch statement, or switch case sometimes. It's a multiple selection statement. It gives your code a chance to select one of like a multiple choice answer, and then an option to get out of it. I'm going to do a little simpler example than your textbook example, and then we'll look at your textbook example. So here's my example. This is an example where you enter a code that a machine is reading out to you, and then the program is going to tell you what the code means. So initially my code tells the user to enter 10, 11, 12, or 13. It is presumed that those are the only error codes that this machine is going to spit out to you. So let's look at how the switch statement works. It starts off with the keyword switch, and the thing that you're going to look at is the thing that has to be tested, and that is, in this case, it's the value of code, and code is an integer. So we could have this case where code evaluates to 10, a case where code evaluates to 11, 12, or 13, and then we have a case that we call default. Let's say the user didn't enter any of the proper numbers, and so I'm going to say, you are an idiot, follow instructions. Okay, so this is what happens. Let's say the user entered a 10, and I'm going to print machine OK, code 10. And then there's a break statement. The break says, I'm done with the switch statement. You can only match one of the cases in the structure. So break means leave the program and go to the outside the switch statement, and leave the body of the switch statement and go outside and continue with whatever else is in the code. So after every case, so say whatever case I match, you do whatever you're going to do, and there has to be a break statement to go with it. That's the end of using this case. Same thing with all the other cases. And your textbook says it's optional to put this default case, the case where nothing matches, but I'm going to tell you it's not optional. It's good programming practice, because your user might be an idiot and put the number 22 in or whatever. So this is the general structure of the switch statement. Now let's look at the textbook example. So here's the textbook example, counting letter grades with the switch statement. So what the program needs to do is repeatedly ask the user to enter a letter grades, A, B, C, D, E, F, and count how many times. So it's a distribution of the grades. So if there's more C's than anything else, maybe you get a bell curve. But a few funny things happen in this program to point out. One is the program says enter EOF character to end the input. Oh, well, what is an EOF character? It means end of file, and it does differ on different systems. On a Windows-based system, it's a Control-Z. I think your textbook has a comment about from other systems here in a moment. If I were the person writing this code, I would say please enter Control-Z to end the user input, because most users are not going to know that EOF is a Control-Z. And then it says while grade equals get character. So this is also an interesting thing. So the program's going to sit there and wait for a get character, so it's going to get the character, and while the character is not the end of file character, then you're going to do this switch statement. And the switch statement is kind of neat because it allows you to either enter uppercase A or lowercase a. In any case, one of these will match, and then you'll increment the A counter. And then, of course, there's the necessary break statement to exit the switch. But rather than going now to the end of the program, you are in a while loop. So you'll go back up here to the while statement and get another character and test. Is it the end of the file character? If it's not, you're going to go match one of these cases, A, B, C, D, or E, or F. And then there's a case for, going on to the next page, there is a case for the user entered an incorrect letter grade. This break is not optional, so don't think breaks are optional. And then you'll print the total counts. So I do have the program here. Here's the program actually, how it would look in your Notepad++. And then I ran and compiled the program, and this is what the results look like. So it says enter letter grades, enter end of file character to end the input. So I did A, B, C, D, E, F. I entered a -1 because your textbook talks about uses of -1s, but that wasn't correct. It just said incorrect letter grade. D, and then an R. R was incorrect, so it tells me that was incorrect. And then and finally I entered a Control Z. Control Z isn't printed. I entered B, and then I entered Control Z. And when I entered Control Z, it gave me all of the totals for how many grades that I had entered. So that's how the program operates. But there were a lot of new things in here. Declaring how many times you're going to count. Mainly, this is the big. I think it's a use of a switch statement, but while the grade, which you get the value from a get character, is not end of file, then you will execute the switch statement, and there'll be some match in the switch statement or no match at all. This is another little interesting part. This is for users being idiots. Nothing happens if they entered a new line. Nothing happens if they entered a tab. Nothing happens if they enter spaces. So that's kind of a neat little feature of this program as well. So you match some case. You get a character, you match some case, either it matches or you give them an incorrect letter grade, or it's a control, or it's a space and tab, or a new line, which case is ignored, or it's a Control Z, which will then get out of the switch statement, out of the while loop, and you will then print the total number of counts. Kind of a nice program. And there you go from your textbook. If you are on a Linux, Unix, it says, or a Mac OS system, end of file is usually a Control D. So depending on which system you're compiled on. We'll see. You're going to compile those of you who are Mac users, you're going to compile it, and then I'm going to try I could try your program out if we have a homework problem like that, and see how it works on portability, how the portability is. That is, it's the ability of the program to go between different computers and operating systems. One more thing about the case switch structure. This is what it would look like in a flow chart. You enter, if case A is true, you do case A's actions, then you break, and then you exit the switch structure. But if case A was false, you go on to the next case, case B. You see if that's true. If that's true, you do its actions till you get to the break. Then you exit the switch structure, and etc. all the way down to the end. If none of case A, B, C, D, X, Y, Z, however many are true, then you do the default action, and then you can exit the case structure, unless you embed it in a while loop like you just did in the textbook example.